been this way from the start. Because the solution for one can be harnessed by others. Because clouds that compete can still connect. Red Hat, our code is open.
Hi everyone, my name is Michelle Gutzait and I'm a Microsoft Data Platform MVP. I work for Pythian. We provide 24/7 services for everything related to data. So most of database platforms, big data, infrastructure, data science, and DevOps. So I'm doing, as part of my job at Pythian, I'm doing a lot of consolidation projects. And I was researching online about SQL Server consolidation. And I only found some conventional methods to do consolidation for SQL Server. So I decided to provide this presentation for you to give you some insight into the type of projects that I'm doing that cover a lot more within a consolidation project. So new features, cloud, and many additional things that we can do when thinking about consolidating SQL Server. And this is a picture of me, obviously, after completing a very successful consolidation project. So the agenda for today, I'm going to talk about your potential current architecture. I'm going to discuss the benefits and drawbacks of consolidating SQL Server. I'm going to discuss the consolidation options for SQL Server. I'm going to compare between the different solutions. So within the consolidation options, I'm going to talk about the conventional ones and additional things that we need to take into consideration. And then I will compare between everything. Then I will talk about how to start a consolidation project and what to do. And finally, I'm going to talk about some helpful free tools, mainly by Microsoft, that help us with the consolidation project. So let's start. Let's talk about your current architecture. So potentially you have a lot of servers with SQL Server instance installed. Maybe you have multiple instances. Maybe you have more complicated than that with high availability and disaster recovery. You may have clusters in there, always on. And those servers may be segregated physically in different data centers or even in different countries. And to complicate things more, you may have dependency of data. So for example, one database requires information or data from another database, either locally or from a far away, physically far away instance. So all those things need to be taken into consideration when we consolidate SQL Server environments. And to complicate things, we may even have different sizes of instances. So in some instances with a lot of databases, some other instances with maybe one or two databases. And we probably have different editions of SQL Server, Enterprise, Standard, Express, Web. And to complicate even more, we may have different versions of SQL Server with different service packs or in cumulative updates. And by the way, the SQL Server 2020 is just a bad COVID joke. We don't have that yet. Let's see what else. We may have physical environments. We may have virtual environments. We may have virtual environments in the cloud already. We may have database in the cloud, so platform as a service. And to complicate even more, we may have multiple instances installed on either the physical server or the VMs. So just to remember, we can install SQL Server anywhere. And from the application perspective, it should be more or less transparent. So you may even have a hybrid environment where you have the physical servers with SQL Server instances. You may have virtual environment on-prem with SQL Server. You may have virtual machine on the cloud, and you may have just Azure SQL databases or RDS. So the more we have things on-prem, the more maintenance and management we need to do. And as we go up the hierarchy to the cloud, we just need to manage a little bit less. So for example, Azure SQL Database, we only have SQL Database to manage in there. Versus physical on-prem, where we need to manage hardware and everything that is installed on top. What else we need to know when we consolidate? So one of the things that we need to look at is the network setup. So for example, if we have a hybrid environment or we are consolidating part of our environment to the cloud, we need to understand how the network needs to be configured. And if we are talking about looking at the consolidation plan, we need to understand the current setup of the network. Another thing that we need to understand is the security. So do we have environments that need to be segregated for different reasons? Do we have security regulations that we need to follow? Do we need encryption? Do we need anything else security related? This is something that we need to consider when we're talking about consolidation. Another thing that we may have is legacy systems, maybe old systems. Potentially the application is installed along with the database server. So the things that we need to consider is, can we separate the database server from the application server for those legacy systems? What can we do? How can we consolidate those? Potentially, we also have vendors that in their contract, they say that if their instance is not separated from others, it needs to be segregated. Otherwise, you don't get their support. So your system is not supported by them. So this needs to be taken into consideration as well. And what happens, for example, if you have an application or an environment where the development team is no longer there, or a vendor that is no longer there? What are we doing with those environments? So let's talk about the benefits and the drawbacks of for a consolidation project for SQL Server. So the benefits, one of the biggest benefits is that obviously you may have less environments to manage because you're consolidating multiple environments into less. Another benefit is that you may lower a license cost on the operating system and the SQL Server side because, again, you're going to have less environments. Potentially, you will also lower the hardware costs because you will have less hardware. But this may not be the case. It really depends on your environment. So let's say that you have a lot of servers that you consolidate to less. So if those servers are not at full capacity and full utilization, you may be able to consolidate them to less with less hardware. So you may save on hardware costs. If your systems are fully utilized, maybe that you consolidate, but the hardware costs are going to still be the same. Another benefit is that you may require upgrading the versions of the operating system or SQL Server instance, or elevate the database compatibility level for the consolidation project. So this could be a benefit if it's time to upgrade your current SQL Server version or OS, or the database compatibility level. But it could also be a drawback because you may have a system where it's very hard to upgrade. So maybe the application is not compatible with the new version that you need. Another potential benefit is that potentially you can lower the human resource costs. So just an example, if you're moving from on-prem to the cloud, you no longer need a team to maintain your hardware. So you can save costs there, but it could be a drawback if you are a part of that team and you need to be laid off. Another drawback is that you may have potential performance degradation because you are placing environments on a more centralized location. So they may compete on resources. Usually this can be resolved, but then you will have higher maintenance efforts to segregate or allocate resources on the consolidated environment. On a consolidated environment also, you potentially have more complex security setup because let's say that you're consolidating into a lot into one environment, you will need to make sure that your security setup is more robust and you have more configurations to do. Another drawback is that the consolidation effort itself may be very high, really depending on your environment. So this is in general the benefits and the drawbacks. And let's talk about the consolidation options. So the first four are going to be the conventional consolidation methods that you can find if you research. The first one is consolidating virtual machines. So let's say that you have few physical servers, each hosting VMs. And you realize that those servers have a lot of capacity and you can consolidate those VMs into one physical server and still have the same performance. So what you save here, you save on the hardware and potentially on the license costs because you're going to have everything licensed to one machine. Another way to consolidate is, as you can see on the left, we have 4 servers, each one with an instance on it installed. So we are able to create a new environment, maybe slightly bigger, depending on the resource utilization on the left, and just migrate those instances and install all of them on one server. So we can decommission the other servers and we can save on license costs there. And potentially also we can save on license cost of the instances if we license per processor. The next way to consolidate is that let's say that we have 2 instances with few databases on each. It could be more instances. And we can just move databases from one instance to the other and decommission the other instance and server. So here we're also saving license costs on the server and on the instance. The last one is consolidating client databases, multiple databases into one single database. So as an example, let's say that we have different database for the same application. Each database, let's say it's a client, and each client is very small. And we realize that we can actually consolidate and migrate everything into one single database. So the maintenance is less. We're going to talk about the benefits of that as well. So this is a rare scenario, and in some cases, this is not very easy. There is another way where you can consolidate multiple databases into a database schema under the same database. So instead of having many small databases, you will have one bigger one. Those were the conventional ones. Let's talk about more options, more exciting options. So I'm just going to lay out the options that we have, and then we're going to talk about the big picture of the consolidation project. So let's remember that we always have the platform as a service, so Azure Database or RDS on Amazon. So this is just a database in the cloud. Basically, you don't have to take care of hardware or operating system. You just have a database in the cloud. But this is not something that is feasible with every environment because those databases cannot actually talk to each other within the database. If they need to talk to each other or get data from each other, they need to do this through the application. So maybe your application is not compatible with that. So there are a lot of features that do not exist if you compare a SQL Server instance on a VM or on a physical box compared to the platform as a service database in the cloud. When you create a database in the cloud, you have to spec it. So you need to say how many vCores it will need to have and how many IOPS or DTUs, depending if you're using Azure or AWS. So Microsoft came up with what is called database elastic pool. Basically, the idea is that you can group number of databases that share resources between them. So when one database has a load that requires a lot of resources, while the other databases do not have the same load, that database will have the amount of resources it needs. So it's very good for a group of databases where the load varies between the databases at different times of the day, and they share resources between them. The problem could be that they can still affect each other's performance because they share their resources. But that's also a very nice feature to have. And basically you can remove a database from an elastic pool. So the database will still exist, but it will not be part of an elastic pool. So you can bring the database out and in an elastic pool within the same tier. Another option that we have is Azure Managed Instances. So managed instance is just an instance in the cloud. So you don't have hardware, you don't have the operating system, it's just an instance in the cloud. And there are few features that do not exist, that exist on a regular SQL Server instance installed on a VM or on a physical box that does not exist on a managed instance, but they're very, very few. So when you decide, if you decide to go with that option, you need to make sure that your environment is compatible with that option. Another exciting feature that we already have for a while is the contained and partially contained database. Contained database is basically an isolated database. So it is not dependent on objects that are in the instance. For example, when you create a regular database, you need a login, which is on the instance level, and then you need to connect it to a user in a database. So when we're talking about contained database, the security is being managed inside a database. So the users are connecting directly to the database. Even if the database is part of an availability group and there is a failover, the users can connect directly to that database. That means that this type of database is totally portable. You can move it from one instance to the other without having to manage the logins or other instance level objects that are related to that database. But the drawbacks is that some features are not supported, such as replication, CDC, change tracking, and numbered procedures. So if you're using those features, this option will not be good for you. Basically, you can administer a database without having to be a sysadmin on the instance. Let's talk about containers. So as you can see in this image, on the left side, you see the virtual environment, and on the right side, you see how containers are. So the way that the VM environment is composed is that you have underneath, you have the infrastructure. On top of it, you have the host operating system. On top of it, you have the hypervisor. And on top of it, you have the guest OS. And on the guest OS, you install SQL Server. When we're talking about containers, we also have the infrastructure, we have the operating system, but then we have the Docker engine. And on top of the Docker engine, you have just the binaries of SQL Server. So as you can see, we don't have the guest OS. That means that we don't need to license the guest OS, and we can save. And by the way, this can be a VM as well. So it doesn't have to be directly on the physical box. So it's very similar to VM, just without the guest OS. The beauty of this is that with containers, there is a persistent storage. So the compute is separated from the storage. That means if there's any problem with the container, it can be recreated in seconds. And also you can just create for the first time a container within seconds. So that also can drive good consolidation method. And the beauty with both of those is that you can still create legacy applications or database applications that way. So you can have previous versions of SQL Server on containers as well. Another nice thing is that they are available on Linux, Windows, and Mac OS, and they work either on Azure or on AWS environments. Another comparably new feature is the serverless Azure SQL database. So when you create a Azure SQL database, you have to spec it, okay, or spec the elastic pool. You need to tell exactly how many resources you need it to have. And there is a flexibility to add and reduce resources within the same tier. If you want to move from tier to tier, sometimes it means a full migration of the database. So Microsoft came up with what's called serverless Azure SQL database. It means that you do not need to spec anything. What happens is that you can utilize resources up to 4 vCPUs, and you're paying by the milliseconds of usage. So if this is good for databases where they are idle most of the time, and then they have a peak batch or peak process that requires maybe almost up to 4 vCPUs, and then gets idle again. And then you just pay per use. What else do we have? Windows and Linux. So you can install SQL Server on Linux. Let's see the benefits. So first of all, Linux is known to be lighter than Windows, and therefore, if you look at the TPCH benchmarks, you will see that Linux performance is much higher, and it's really good performance. If you need high performant systems, this may be the way to go. And also when we discuss consolidation. The same features of SQL Server exist on Linux, so you have no compatibility issues. In terms of the price, you don't need Windows licenses, so you save in there as well. And when you use Linux, usually you would go with the open source databases, but SQL Server has many features that you don't have on the open source databases. Hence, it's becoming something that some organizations are considering moving from open source to SQL Server on Linux. So I talked about the options, and let's try to bring examples on how to compare. And why I put oranges and apples, because as you could see, some of the options, it's very hard to compare. Some of the options is very hard to compare on a high level because it really depends on your environment and what you have. So I provided 3 examples of comparison. This is the first one. So usually when I do something like this for a client, I compare solutions, and instead of explanation here, I just put a rank. So it means, okay, this one is a better solution for that. This one is the medium solution, and this is the worst solution. And then I provide some explanation why is the solution better. So just to give you an example, so this is very hard to create because some of those depend on many factors. So let's just give an example. Let's go to security. So this slide is comparing on-prem between virtualization versus instance consolidation versus database consolidation. So virtualizing few instances per OS and few database per instance. So from security perspective, this one is the most secured. Why? Because when you have one instance per VM, everything is segregated. You segregate the instance, you segregate the machine, and you don't have multiple instances on one machine. When we talk about few instances per OS, you have few instances on the same operating system. Therefore, the instances themselves are isolated, but it's the same OS. So the file system is not segregated. You need to add a layer of security. When we're talking about database consolidation, that means that we have more databases under an instance. It means that the databases are isolated or partially isolated, depending on what you need, but it's the same instance and the same OS. So you need to add a layer of security in there too. Let's talk about the, let's say the hardware costs, okay? So the hardware costs, this really depends on the architecture. However, you have more flexibility to move VMs across, right? So we may not save on the hardware, but we have more flexibility here. When we consolidate more instances on a server, we may need a bigger server. But if we need to compare between the VM and the server, probably the VM is going to be bigger because you have multiple operating systems in there. While when you consolidate on the same server, you have only one operating system and multiple instances. So you may need less hardware. When you consolidate a lot of databases under one instance, you don't have multiple operating systems. You don't have multiple instances fighting on resources. You just have the databases fighting on resources. So you may pay less for the hardware. Those are the examples. Let's proceed to the next example. So this is a slide that is trying to compare between on-prem, physical or VM, and IaaS, so a VM in the cloud, and PaaS, cloud database. So let's just look at an example here, hardware. So obviously, when you do on-prem, you have hardware costs, but when you do cloud, you don't have the hardware costs, but you have other costs. So if you look at the total cost, it may be equal. It depends what you're doing. Usually, when you move to the cloud, the total costs go down because you don't need the team that will manage the infrastructure. Let's talk, for example, about the manageability. So when you have on-prem, you need to manage the hardware, the VM, and everything on top of it. So the OS, and instance, and database. When you have the IaaS, the cloud VM, you don't have the hardware, so you have OS, instance, and database management. And obviously, when you go to PaaS, you only need to manage your database. So if you compare here, you will see that the cloud database is better from that perspective, but it may not be the best solution for in other perspectives. Let's proceed to the third example. Let's compare between virtual environments and containers. So for example, let's talk about the segregation, the performance. So with virtual machine, you have segregation of machine per VM. So basically you can create different specs per VM, which could be prone to changes. So you have some flexibility on the VM level to get better performance. And you can also move VMs. If you have more than one server, you can move VMs for performance. With containers, you have only one operating system. Hence, the containers share all the resources on the host, but you don't have operating system per instance, hence the performance may be better with containers. So that's all. That's more or less an example. So we have more to it, and really depending on your environment and what you're consolidating. So what's next? Let's see. So we know the options, we compared the solution, and let's see, where do we start? So I've created some kind of a checklist, high-level checklist, with the goal. My goal with the consolidation projects is usually to reduce cost. If your goal is different, you may require a slightly different checklist. So let's see what I have here. The first thing that I recommend is that you need to inventory instances, application database, and owners of the databases and the applications, because you need to understand what you're going to be consolidating. You need to know what are the instances, what are the servers, each instance, where it resides, either it's virtual or physical, which applications are using each one of the databases, and who are the owners so that you can talk to them if you need to test. So from here, you decide if you know everything and you can start consolidating. And from here, you have a list of environments that you can consolidate. Once you have all this information, you also need to understand the SLAs. So SLA could be downtime, could be performance, could be recoverability. So you need to make sure that you understand the SLAs. Just an example, if you have a critical environment with a heavy load, you may not want to consolidate that one because you need to have a very high SLA. If you have lower SLAs, my recommendation is to try to group the environments by the SLAs, because you will probably want to create high availability and disaster recovery solutions, maybe backup solutions that are specific to those SLAs. Anyways, even if you don't group the environments by that, you need to know those for your final solution. Another thing that I recommend is that you need to review the current capacity and performance of the environments. Because let's say that you have a server that is very large, but it's not fully utilized. You need to know that, because when you are going to consolidate or move it, you will know exactly how many resources it needs. Because if you just do apple to apple, you may not save the costs. So when you consolidate, you need to understand what is the capacity that you need in the consolidated environment. And you create that capacity measurement based on the current capacity. Obviously, you also need to think about the future capacity. So you may need to allow for a space to grow. Another thing that we need to do is to review the isolation requirements and the security requirements of the systems. So if we need isolation or segregation or specific security standards, we need to know that. And hence, we will know which systems can be consolidated and what is the level of security configuration that we will need if we consolidate those systems. We need to review the dependencies to other databases or instances. So if you remember from my first slide, we may need to get data from a local instance, a different local instance, or a different remote instance. We need to know those relationships, because when we consolidate, we need to make sure that we either group those databases or instances if possible. Sometimes it's not possible because they need to stay on different physical locations, but we need to make sure that we can access that data. Maybe if we replicate, we may have different solutions to replicate data to different locations. So that needs to be taken into consideration. Very important to assess the current cost of the environment, because we will need to compare it to the future environment, to the future consolidated environment. We need to assess the future budget, and I'm going to explain. The consolidation project itself has its own cost, right? So we need to make sure that everything is within our budget, including the estimated cost for the consolidated environment. So we need to discuss the cost with the vendors. So if the vendors are part of the consolidation project, let's say that the vendor has to move or migrate their environment or upgrade their environment, we need to know those costs. And also, let's say that if we would like to consolidate, let's say to Azure, and we do have a Microsoft representative that we're in touch with, we may get some deals from that representative, and we need to know what will be the costs. Maybe we will not get the public costs, maybe we will get some deal. So we need to know that. We need to, if we're upgrading environments as part of our consolidation, we need to assess if it's even feasible to upgrade those environments. We need to verify that the consolidation options that we're choosing, that our environment are have the feasibility to be migrated to those. For example, if we decided to consolidate databases on a managed instance on Azure, we need to make sure that we're not using features that are not going to be supported by that environment. And if we do have features, we need to maybe try and find alternative solutions to those. And this needs to be integrated into the cost of the consolidation. So we need to estimate the cost of the consolidation project, as I said. And then finally, we need to estimate the cost over time of the consolidated environment and compare to the current. So to give you an example, let's say that we estimate that the consolidation project will cost us $1,000 US, just the consolidation project itself. Let's say that we estimate that the cost that we're going to save on cost $20,000 US per year on the consolidated environment. That means that in 5 years, okay, so we spend $1,000 on the consolidated project, where we have $20,000 less per year that we have to pay on the consolidated environment. So that means that in around 5 years, we're going to be even. And only in the 6th year, basically we don't know when the consolidation project is over, but the 6th or the 7th year, we're going to start saving $20,000. So we need to know all those to make sure that consolidating makes sense. If your goal is not to reduce costs, you may have to change the checklist for the that is related to the costs. Let's talk about the high-level strategy to consolidate. So basically we have everything. We gathered all the information that is required in the checklist. We know what we have. We know what we can consolidate. We know what is feasible to consolidate and how. And now we need to come up with a strategy, a methodology, and maybe a plan. So it doesn't mean that we need to consolidate everything with the same option. There may be different consolidation options. Just an example, maybe we are going to move only 80% of our environment and consolidate to the cloud, and 20% we may consolidate with VMs. So we may consider multiple options of consolidation in one consolidation project. We need obviously to assess the feasibility once we have the different consolidation options. And when we try to assess the feasibility, we may have to change the options based on the results. This is a recommendation by me. Unless you have a very small environment, I would recommend to do a step-by-step consolidation and not everything at once, because that makes more sense, especially if you have a very large environment. This way you can manage and control things like cost, like performance, and other things. We need to create a list of candidate database and instances by priority. Now, by priority, I'm not talking about criticality. I'm talking about when you decide to do a step-by-step consolidation, you want to pick and choose your candidate database on instances that are going to be consolidated, and you're going to work on them as guinea pigs, just to make sure that what you're doing is the right way to go. But of course, you're not going to go directly and do this in production. You actually need a proof of concept and a lot of testing. So when we're creating a proof of concept, it really depends on your environment. If we're talking about different environments, we would like to make sure that we're testing each one of the different environments with the option that we chose. And we have to test everything. We need to test the migration / consolidation / upgrade of the database environment, and then test the applications against that to make sure. So what happens if, for example, we did not check feasibility of everything, because it's very hard. How do you assess feasibility of the code that is coming, the database code that is coming from the applications? So we need intensive testing. Another tip that I would give you is that I would recommend to take a performance baseline before and after the consolidation / migration / upgrade, because if you hit performance issues, you would like to compare the before and the after and understand what are the bottlenecks and how to resolve them. So this is very important. Always create a rollback plan. So what happens if everything goes well, the testing went well, and then you go production and something is not going well? You need to roll back to what you had before or something very close. So always have a rollback plan. Always decide how much time into the new production the application or the database environment will be declared as successful. So let's talk about some helpful tools. All of those tools are free, and most of them by Microsoft. All of them by Microsoft. So the first tool is the Microsoft Assessment and Planning Toolkit, or the MAP tool. So this tool is, you install it on a machine in your network with enough permissions to run WMI, Active Directory, domain services, and SMS provider, and get information from different servers, all the servers in your environment. And this tool allows you to inventory everything in your environment. As you can see, you can inventory servers, desktop, things that you have in the cloud, databases, virtualization, and so forth. So it just goes and scans your entire network and provides you with specific numbers and specific information that you're looking for. So it inventories computer, hardware, software, and operating system, and you don't have to install anything on the target systems. Only in one place. It also, except for inventory, it also helps you with assessing migration, upgrades, consolidation, and moving to the cloud. So it gives you all kinds of recommendations about what you can do, and consolidation is what we are looking now. So this tool is very good. If you haven't used this tool in the past, I recommend you download it. It's free, and you may try to just run it and see your inventory and the details. So this tool creates 2 Excel files with all the information. Try not, if you have a huge network, try not to run it on everything. You can give it a list of servers or IP range, IP address range, or you can just run it for your database environment. Another tool is the Microsoft Data Migration Assistant, or a DMA. So what this tool helps you is to upgrade from a previous SQL Server version to a new one. What it does is that it scans everything and it detects compatibility issues that can impact database functionality, and it also gives you some warnings about things that are going to be deprecated. It also recommends performance and reliability improvement for target environment. For example, if you have a query that will not perform better on a different version, on a higher version, the tool is going to let you know. Except for detecting and recommending, it also allows you to do the actual migration. So moving the schema, the data, and the uncontained object from the source server to the target server. So the actual migration or upgrade migration. So these are the sources of SQL Server from 2005 to 2017. And the targets are 2012 to the latest, and also the cloud options. So this is a very nice tool. I've used it many times in the past, and it gives you a lot of insight into the upgrade/migration. Another tool is, I haven't talked about this, but maybe as part of your consolidation project, you would like to migrate from a different database platform to SQL Server. So this tool, the SSMA, the Migration Assistant, is designed to assess first, and then if you decide to migrate, also automate the database migration to SQL Server. So from Microsoft Access, DB2, MySQL, Oracle, and Sybase. And for each one of those, you have a different setup that you download. For example, this one, Microsoft SQL Server Migration Assistant for Oracle. If you are downloading one for MySQL, you will see here MySQL. So it's a different agent per database platform. And what it does is that it assesses how many objects or items can be migrated automatically. And it also assesses how many cannot be because they're too complicated. Usually it's related to code like store procedures or triggers. And it estimates for you the manual work that it will take you, the amount of time that it will take a developer to make the changes manually. From my experience, usually it's overestimates, but it gives you some idea of the migration effort. Another amazing tool is the Microsoft Performance Analysis of Logs. So you're using Performance Monitor counter. In the documentation, you have the specific counters that the tool needs for the reports. And then the performance counter generates a CSV file, and the PAL analyzes that CSV file. It could be by time range. And it generates a report with all the issues, either by time slices or by issue. Memory, for example, you see here memory, available megabytes. So each one, if you click on it, it will give you a description of what has been reviewed with that counter, the expected values, some links, and then a graph. And then underneath the graph, you have average, max, and min. And under that, you have all the warnings or errors that may indicate bottlenecks in your environment. So my recommendation is to run this before and after the consolidation/migration/upgrade, but the tool doesn't have the ability to compare. What it has, you can give it multiple files and then it will scan all of them, and this way you may be able to compare, but there are third-party tools that can compare better performance of before and after. Another great tool is the Azure Migrate. The Azure Migrate assesses and migrates on-premises servers with the infrastructure and application and the data to Azure. So what it assesses, it looks at the environments and it assesses their readiness. Can this environment be migrated to Azure, and to which option? It also estimates the sizing that you need on Azure, the cost estimates, and dependency analysis. So which databases will need to move together, which ones cannot, for example, move to SQL Azure database because they have dependency, and everything. So it will give you an idea if you are able to move specific environments to the Azure options that you're looking at. So just for the assessment, you need to install it on just a server in the environment, but nothing has to be installed in the assessed environment. But the tool also allows you to do the migration itself. And this is a little bit more complicated. I posted the link here. It allows you to migrate from on-premises to Azure with minimal downtime. And if you look in the background, you can see that this is using replication. So you have to install an agent on each of the migrated environment, and it works with replication in the background. And if you're interested in the application sides, Microsoft has just purchased Movir, which allows you to also analyze the migration of applications. And the tools that we've seen before also give you some estimates around the prices, but if you'd like to do a little bit more calculation or more accurate calculation with specific sizes that you think that the tools did not accurately estimate, you have two calculations. This is a URL, one for Azure and one for Amazon. So as you can see, in Azure, for example, you can decide to estimate how much this size of virtual machine will cost me. It will ask you a few questions. You can add Azure SQL databases. You can say how many would you like and what is the size, and the calculator will give you the price per environment and total price. So you can play with those estimates and see how much eventually it estimates that you will need to pay. So you have the ability to pay either per hour, depending on the option that you're choosing, per hour or per year or per 3 years or per millisecond. I haven't tried yet if the serverless is already there, but if not, probably Microsoft will add that option to the price calculator. And it's the same with Amazon. You need to understand how the price calculator works, how the environments are built, and in order to be able to estimate estimate the specs that you need and get the pricing, the total pricing. So these are very nice tools. Just as an example, if you know more or less the specs that you have right now and you think that you will need to consolidate to more or less the same, you can just use those calculator to estimate how much the consolidated environment will cost you in the cloud, of course. On-prem, it's a little bit more complicated because you have a lot of components in there. Let's move to the last part of this presentation, which is the case studies. So I have 3 case studies to discuss. The first one is database consolidation. So this is a client that I actually had. I had a client that when they built their application, they decided to go with a database per client. And they did not know how big they will become. And they eventually became so big that they had 30,000 or 20,000 database clients. So that means 20,000 or 30,000 client databases. And most of them were very small. So what they had to do is that they had a lot of databases. They had few instances and a lot of databases, small ones underneath. And they decided to consolidate the small ones into one big database. So it's the same application, the same exact database schema. They did have some version differences that they needed to fix before the consolidation. The database was per client, many small databases. They had a lot of maintenance overhead because they had to manage so many databases, and they decided that this is not the way to go. we reviewed the performance of the databases, and we decided that they can actually consolidate into one database. They were considering cloud versus on-prem, and they eventually decided to stay on-prem on a virtualized environment. The next case study is an instance consolidation. So that specific client had many instances, one instance per server, hosting few databases. It was the same version in addition. All the instances were the same version in addition. They had no security constraint or isolation requirements for the instances. So basically they were able to consolidate. They had to manage too many servers and too many instances. So that was an overhead for them. And they had to pay license cost, obviously, per operating system and per the instance. They also needed to add high availability and disaster recovery layer. And they were considering cloud versus on-prem. So basically what they ended doing, they ended having like just migrating all the databases under one instance. So they were saving on license costs of the operating system and of the instance. And they went on a VM in the cloud. And the last example is for the database serverless. So as you can see, this example shows that the database, specific SQL database, Azure database, is idle most of the time. And then it has a process that has a peak of 80% out of the 4 V cores, and then it gets idle again. So if you estimate the cost, if you know exactly how the database behaves, you can check the costs. So in this case, those are the estimated seconds that was supposed to be billed during that period, within a period of 24 hours. And they estimated that the unit price is this per vCore per second. And when they calculated everything together, they saw that the cost is $3.50 US for the 24 hours period. So that way, because the database is mostly idle and only working a little at full capacity for a certain amount of hours, the serverless is a good option for that specific database. So special thanks to Microsoft for supporting and sponsoring the event. And please don't forget to do whatever you need to win the prizes. And that's it for my presentation. I thank you very much. This is my email address, and feel free to email me if you have any question. And also you can post your questions here after my presentation, and I will try to answer your question. Thank you very much.
Because we've been this way from the start. Because the solution for one can be harnessed by others. Because clouds that compete can still connect. Red Hat, our code is open.